Hi everyone, we're going to talk a little bit about kinetics. Just a little bit about it is going to carry us through the next couple weeks. This one's going to be about rates and collision theory. Now, a little background. Kinetics is how fast or the speed of a chemical reaction. That's the rate that we're going to be talking about. You're going to hear a little bit about mechanism once in a while. That's how it happens. And remember, whenever we have a reaction, it's going to make or break bonds. H2O, when we break those bonds, we end up with hydrogen and oxygen. We have to break the bonds in order to make new ones. Now, there's a couple factors, there's 5, that affect reaction rates. Nature of reactants. What is it made of? We know that covalent bonds share electrons. Ionic bonds don't. They transfer their electrons. What phase they're in. When it's a solid, everything's really close together. When it's gas, they're really far apart. That all factors into how fast something can react. Now here's a main one for you. Ionic reactions occur very fast. It's because, they're next to each other, but they're not sharing anything. They can be broken apart. Covalent reactions, which are sharing those bonds, they can't break apart as easily, so they occur very slow. And there's some information why as to if you want to read it. Another thing that affects reaction rate is concentration. This only applies to gases and mixtures. Now, one of the things you're going to be doing in your homework is looking at a demo about concentration. And it has to do with a mixture. It will look like a liquid, but it is a mixture. And then there's a little bit about pressure here. When we increase the pressure for the gas, it's the same as an increase in concentration. Next one, temperature. This one should make sense to you. You should know this. If we heat something up, those particles are moving faster. As those particles move faster, they're moving around, they're going to hit. If they hit more, they can react. So the more energy something has, the more collisions, which means the rate's going to increase. Opposite would happen if we cool it down. Those particles move slower. They might hit, but they might not have enough energy. Surface area is another one. We have more surface area, and yes, we're getting into a little bit of geometry here. Not much though, no calculations. The more particles are exposed. So if I go like this, you can just see pretty much the outsides of my hands. When I open those up, there's a lot more surface area because you have the inside and the outside of both hands. More surface area, more places for collisions. This all comes down to how much can collide. Now, we do have to talk a little bit about a catalyst because a catalyst can really speed things up. And you're going to see that in the video. A catalyst speeds up a reaction because they're changing that mechanism. They're changing the steps. It's sort of like a shortcut. It decreases the amount of energy needed, and we're not going to get into activation energy really until the week after or maybe 2 weeks from now, but that's okay. A catalyst is not consumed by the reaction. So if I put a catalyst in, that catalyst is still going to be there at the end of the reaction, no matter what. And then energy. We have to say something about energy because we're getting into a unit about energy. Reactions. If we have a glass of water on the counter, it stays water. We can break it apart into that hydrogen and oxygen. We can break it apart, but we have to have some energy to break it apart, and that starting energy is called activation energy. So that catalyst gets that energy going. It lowers that activation energy, and you're going to be drawing some diagrams later in this unit to show this. Not yet, though. Not today. And finally, I've been talking about collisions. Collisions are very important in this unit. Collision theory. Particles have to collide. So if we've got two particles and they completely miss each other, no reaction. They have to collide with enough energy. So if they just sort of tap each other, not gonna have enough energy to react. They must be oriented properly. So if I want them to go together like this, but my hands are mixed like that, improper orientation won't react. And it has to hit all of those. They have to collide, they have to have a lot of energy, and they have to orient properly in order for there to be an effective collision. Once there's an effective collision, we can have a reaction. And I know that was a lot of information, a little bit of time. It's here for you to watch again if you need. You do need to know all 5 of those things that affect rate.